If you're new around here, welcome. I'm Afan, and I'm all about bringing you awesome content that'll make your day brighter and your mind sharper. So why not join the fun? Hit that subscribe button and smash the bell icon to stay in the loop.
Look up at the night sky far beyond the familiar stars. You are looking into the vastness of space, a realm filled with countless galaxies. Galaxies are immense collections of stars, gas, dust, and mysterious dark matter, all bound together by the relentless pull of gravity. Like celestial islands scattered across the cosmos, these luminous structures hold billions upon billions of stars, each a sun in its own right, some perhaps harboring planets like our own. Our galaxy, the Milky Way, is just one of these cosmic islands. When we gaze up at the Milky Way on a clear night, we are seeing its disk of stars from within. It appears as a faint band of light stretching across the sky, a river of stars flowing through the darkness. But if we could travel outside our galaxy and view it from afar, we would witness its majestic spiral structure, its arms swirling with star-forming regions and glowing nebulae. The study of galaxies is a journey into the depths of the universe, a quest to understand how these magnificent structures formed and evolved over billions of years. It is a story of cosmic drama and wonder, of colossal forces shaping the cosmos, of stars being born and dying, and of the intricate dance of gravity that binds it all together. In the vast expanse of the cosmos, galaxies are the fundamental building blocks of the universe as we know it. Join us now on a journey to explore the origins of these celestial wonders, from the earliest moments of the universe to the diverse array of galaxies we observe today. To understand the formation of galaxies, we must rewind the cosmic clock to a time shortly after the Big Bang, the event that marked the birth of our universe. In the first fleeting moments, the universe was an unimaginably hot and dense soup of elementary particles, but as the universe expanded and cooled, protons and electrons combined to form the first atoms, primarily hydrogen and helium. This primordial gas, the raw material for future galaxies, was not uniformly distributed throughout space. Tiny variations in density, remnants of quantum fluctuations from the Big Bang itself, created regions where matter was slightly more concentrated than elsewhere. These subtle density fluctuations would act as seeds for the growth of structure in the universe, eventually giving rise to the galaxies we observe today. Imagine this early universe as a vast dark ocean of gas, almost perfectly smooth, but with the faintest ripples disturbing its surface. These ripples, representing the density fluctuations, would grow over time under the relentless pull of gravity. As the universe continued to expand and cool, the stage was set for gravity to begin its work, pulling together the primordial gas and setting in motion the formation of the first stars and galaxies. Gravity is the architect of the cosmos, the invisible force that shapes the universe on the grandest scales. In the early universe, gravity began to exert its pull on the primordial gas clouds, drawing matter towards regions of slightly higher density. As these regions grew in mass, their gravitational pull strengthened, attracting even more gas and amplifying the density contrasts. Over millions of years, these collapsing gas clouds called proto-galaxies became denser and hotter. The gravitational energy released during this collapse heated the gas, causing it to glow at increasingly higher temperatures. These proto-galaxies, illuminated by the heat of their own collapse, were the progenitors of the galaxies we see today. The process of gravitational collapse was not uniform throughout the early universe. Some proto-galaxies formed in relative isolation, while others clustered together in groups, drawn together by their mutual gravitational attraction. These early galaxy clusters were the seeds of the larger-scale structures we observe in the universe today, such as galaxy clusters and superclusters. As gravity continued to sculpt the early universe, the stage was set for the next crucial stage in galaxy formation, the birth of stars within these collapsing clouds of gas. Within the dense, turbulent hearts of proto-galaxies, conditions were ripe for star formation. As gas clouds collapsed under their own gravity, they fragmented into smaller, denser clumps. These clumps continued to contract, their cores becoming increasingly hot and dense. Eventually, the temperature and pressure at the center of these collapsing clumps reached a critical threshold, igniting nuclear fusion and giving birth to the first stars. These first stars were very different from the stars we see today. They were massive, short-lived, and composed almost entirely of hydrogen and helium. As these stars burned through their nuclear fuel, they released enormous amounts of energy, heating and ionizing the surrounding gas. These stellar furnaces played a crucial role in shaping the evolution of early galaxies. The intense radiation from massive stars created powerful stellar winds that blew away surrounding gas and dust. These winds helped to regulate star formation, preventing galaxies from converting all their gas into stars too quickly. They also enriched the interstellar medium with heavier elements, the building blocks of future generations of stars and planets. As stars lived and died within these early galaxies, they enriched the surrounding gas with heavier elements, setting the stage for the formation of more diverse and complex stellar populations.